So today we are starting 7.4, day 1. We're solving polynomials today, and we're going to use what's called the zero product property. So as to intro, I'm going to read what's in the box here, and then I'll kind of explain through a picture. So what the zero product property says is that if we have two real numbers, and when we say real numbers, that just means you don't know what an imaginary number is yet. You'll get to that when you're a junior or when you take Algebra 2. But take this, when you multiply two numbers together and their product is 0, that means that at least one of the numbers has to be 0 as well. Have two numbers. Let's say we're going to use letters to stand for numbers now. Let's say we have letter A times letter B, and it's equal to 0. Well, we can say that, well, either one of them has to equal 0 or both of them have to equal 0. How we know that works is the only way when we multiply two things together to get to 0 is if one of them is 0. So let's say in this case that our B value is equal to 0. A times 0, whatever number A is, that's always going to be equal to 0. Same thing if we flip it. Let's say our A value now is the number 0. And we don't know what our B is. It's just some number B. Well, when you multiply 0 times B, it's still going to be equal 0. And if A and B are both equal to 0, 0 times 0 is 0. So this is what we call the zero product property, or ZPP. I'll abbreviate it as. So what we've been doing over the last couple of days may have seemed like you're kind of like, we're doing one thing, moving on to the next, then doing another thing. At one point, everything we've done through this chapter is all going to come together and you'll do everything at once. So it's important that you're taking the time and building these skills. We're just taking little bites at a time, and then when we get there, we'll take a big bite of everything. So how this works when it comes to solving. So first thing, we're not going to be finding the product. We have to solve for x. And each time we're solving for x, we're going to use our zero product property. So let's take example A for example. We have x minus 3 in parentheses times x minus 9. This is a product. So these two, when they're multiplied together, is equal to 0. So that means this parenthesis has to equal 0, or this parenthesis has to be equal to 0 to get this to 0. Think of this as what we talked about just in that last example. This is kind of like your A, and this is your B. If we're multiplying two things together and they're equal to 0, one of them or both of them have to be 0. So how you actually use this to solve is you're going to take the first parentheses and set it equal to 0. So I'm going to take this x minus 3 and set it equal to 0. And then I'm going to solve for x. So to solve for x, it would be super quick. We would just add 3 to both sides. Plus 3 and plus 3. So x is equal to a positive 3. That is one of our answers. We're going to have two answers. That's one of them. X is equal to positive 3. How we find our second answer is by taking our second parentheses and setting it equal to 0. Setting it equal to 0 is finding the value of x that makes one of these parentheses 0, so then we can use our zero product property. So to solve, we'd have to add 9 to both sides. Then we get our value for x. Plus 9 and plus 9. So x is equal to 9. That's our second answer. So here's what you may call like your check step. You don't have to do this every time, but I just want to show it to show you how, like why we're doing this and how it works. So here's our check. Let's say that we use one of our answers. We say, all right, x is equal to 3. That means wherever we see an x in our original equation, we're going to plug in a 3. So this will be 3 minus 3 times 3 minus 9 is equal to 0. Well, 3 minus 3 is 0 times 3 minus 9 is negative 6. That's equal to 0. So what 3 does is make this parenthesis equal to 0. And if this, one of them is equal to 0, we could say that both sides have to be equal to 0. Because you take 0 times negative 6, this goes back to 0, equal to 0, and that's true. So we know that's how we check our work. We know we did it correctly. You can check as well for x equal to 9 by doing the same thing. Plugging in a 9 wherever you see an x. So we say 9 minus 3 times 9 minus 9 equals 0. Then 9 minus 3 is a positive 6. 9 minus 9 is 0. So again, we have a number being multiplied by 0. Any number multiplied by 0 is still 0. So then we have 0 equal to 0. So this, right now, what we're practicing, this is one skill that you're going to use in a longer type of problem. So again, the stuff on the left side of the squiggle is what you'll be doing in every problem. The stuff on the right side is not required. It's just a way to check that you're doing it correctly. All right. Let's do the second example, B now. I'm going to keep writing in 2 colors to show I'm setting one thing equal to 0 and then the other thing equal to 0. So first, you put your first parenthesis equal to 0. Z minus 4 equal to 0, and then you could just go through and solve. Well, to solve, we'd have to add 4 to both sides, so plus 4, plus 4. So Z is equal to a positive 4, and there's one of your answers. And then you take your second parentheses, which is your second term, and set that equal to 0. So you say Z plus 6 equal to 0. So to solve, you'd have to subtract 6 from both sides. So your other answer would be Z is equal to negative 6. All right. So example C now, it looks different, but we're still going to use the same zero product property. Except now think of this as our first term and this as our second term, or as our A and our B. When you multiply 2 together, it has to be equal to 0. So you always do, you always take your first term, set it equal to 0. Say 2x equal to 0. And then solve for x. Well, to solve for x, we have to undo this multiplication here. This 2 times x, so we have to divide each side by a positive 2. 0 divided by 2 is always going to be 0. So we know that one of our answers will be 0. And then we go and find the second one. Both are important. You can't just find one. You got to find both. X minus 4 equal to 0. Super simple. Add 4 to both sides. X is equal to a positive 4. If I was to plug in 0 or 4 into my original, it would set my whole left-hand side equal to 0, which is what we want. All right. Hopefully now you're kind of getting the hang of it, seeing where we're going with this. So an example like D, the same thing. Think of this as your first term being multiplied by your second term. You want to see, okay, I want to set both terms equal to 0. This would be, it's just an x, so we just say, well, x is equal to 0. We already have one of our answers. Our other one, x minus 5 equal to 0. We just have to do one extra step to solve. We have to add 5 to both sides. So x is equal to a positive 5. There's our second answer. You can always go back in and check. Should always be plugging them in and seeing, does it get back to 0 when I plug it in? All right. We're going to take just one more step in difficulty because it's just adding an extra step. We're still going to use our zero product property, which if you ever see me write ZPP on like a note sheet or an answer key, that just means I'm using my zero product property. So that means I'm setting my first term equal to 0 and also my second term equal to 0. And I'm solving both of them. You could solve one at a time or you can solve them both at the same time, however you want to do it. So we're solving for red now. You would add 4 to both sides. So you would have 2x is equal to 4. And then you would have to divide each side by 2. So x is equal to positive 2. That's one of your answers. And this is just the extra step in difficulty. Instead of having a one-step equation to solve, we have 2 steps. We have to move our constant over, and then we have to divide to get our variable alone. So for our blue equation, we'll say 3x. We would have to subtract 6 from both sides. So 3x is equal to negative 6. And then divide each side by 3. So x is equal to a negative 2. Sure. All right. F, same deal. We're going to have 2 steps to solve. First, set your first one equal to 0. 4x minus 7 equal to 0. Solve for x. 4x is equal to, we add 7 to both sides. So 4x is equal to a positive 7. And then you have to divide each side by 4. So x is equal to 7 over 4. Should we freak out if it's a fraction? No. Fractions are okay. You could write it as a fraction, or if you wanted to put it into a decimal, you could write your answer like that as well. This will be 1.75. Just want to make sure if you have fractions in your answer, don't have like a fraction for one and a decimal for the other. Make sure it's the same. Then you do the same thing for the other one. 2x plus 9 equal to 0. We would have to subtract 9 from both sides. Again, each time I'm moving my constant term over first. And then we would have to divide each side by 2. So x is equal to negative 9 over 2, or negative 4.5. All right. So we do one more example, I guess 2 more examples, but they're both quick. If we have 3 terms, what do you think we do? Same thing. We're just setting all 3 equal to 0 now. Because even if one of these is 0, think of it, we have, this is like an A, this would be our A, this is our B, and if we introduce a C, if just one of them is equal to 0 and we're multiplying by the other 2, 0 is kind of like your trump card. If you're multiplying by 0, your 0 is going to take over. So I'll say this parenthesis is 0, we multiply it by this parenthesis, it's 0. Then we multiply by this parenthesis, the whole left side is 0. So we could just do this by saying, well, x plus 1 is equal to 0. So x is equal to negative 1. say x minus 3 is equal to 0. So x is equal to a positive 3. And then you can say x minus 2 equal to 0. So x is equal to a positive 2. And then last kind of unique case that you may have is if you have something squared. So like in example G, well, something squared we talked about yesterday, that's just a number or a polynomial multiplied by itself. So this is just going to have one answer. It's both x minus 1 equal to 0. So together, your one answer you have is x is equal to positive 1. So again, kind of the steps in this in terms of what to do like math-wise, I think you all can handle. What I want us to kind of think about more is why this works. Just like you have to convince yourself that if one thing is 0 and I multiply it by anything else, the 0 will take over. The 0 is kind of like the trump card, like I said.